This is a calorimetry problem because we have two things that are changing temperature. So let's make a diagram of the changes in temperature. We have something that starts at 35 degrees C, our water bath. Our metal starts at 137 degrees C, and they both end up at the same temperature at the end, which is 41 degrees C. This leads to two values for delta T. For the metal, we have the delta T, as always, is TF minus TI. The final temperature for the metal is 41. Its initial temperature is 137. So we have a value for delta T of minus 96 degrees C. For the water bath, we have a different starting temperature. So delta T is going to be the final temperature minus the initial, as always. The final temperature is 41 degrees C. However, the initial temperature is 35. So we have a delta T for the cold water equal to 6 degrees C. The first law tells us that the energy of the universe is constant, and therefore the heat gained plus the heat lost has to sum to 0. We remind ourselves that it is the water bath that's gaining heat, it's increasing in temperature, and that metal is what's losing heat, it's decreasing in temperature. For each of these, we apply the equation that the heat is going to be equal to the mass times the specific heat capacity times delta T, although the values of these variables differ for the water bath versus the metal. In this problem, we need to calculate the mass of the water. That is our unknown. So we apply the equation that the mass times the specific heat capacity. To make our math easy, we'll use the value in calories, 1.00 calories per gram degree C, which is equivalent to this given value, just in different units. Our delta T, as we've seen below, is 6 degrees C. Now we'll apply the equation to the silver metal. We're told we have 75 grams. Its specific heat capacity is something we can look up or be given in a question statement. This is 0.564 calories per gram degree C. And we're going to multiply by our delta T, which is a negative 96 degrees C. And these values together need to sum to 0. Okay, we're going to do our calculations, and for the moment, ignore units. So we have 6 times the mass plus a negative 460.8. And we get that value from multiplying 75 times this number times minus 96. All of these values together need to sum to 0. Let's add 460.8 to each side, so we have 6 times m is equal to 460.8, or our mass is going to be equal to 460.8 divided by 6, and our calculator answer is 67.68 units of mass are grams. Let's look at our sig figs. We're going to be limited to 1 sig fig because of that number here. We can only use 1 sig fig in our answer. We'll have to use scientific notation. I'll first convert this to scientific notation, and then that rounds up to 7. Our final answer is 7 times 10 to the first grams.